Hey, what's going on? And this is another episode of the Daily Math Dream Khan Academy. I'm using two-step equations at the work I'm actually going to be working on today. And the idea of two-step equation is when you have an algebraic function or algebraic equation that takes two steps to solve. And mainly when we do it, we will have one side of the equation that usually has, for example, this one has 3q minus 7. So we would have to first get this expression into something that's easily solvable. So we would probably use the distribution on this side to end up with 3q, because 3q would mean 3 times q minus negative 21, which is pretty much 3 times negative 21. And then we would basically put the minus in front of it, and then it would also be equal to 27. So what we're basically getting here is what is we used up here. So what I did was that once we multiply these things to each other, we end up with this. When we multiply 3 times q, we end up with this, because we don't know what q actually is. This is how we multiply variables. The idea is I'm trying to put together a situation that's easy to solve on your own. So that would be the first step. And the second step would be to solve, put 21 on both sides of the equal sign or the equation. And then you would have 21, and then you have plus 21 on the side. And then that will be equal to, let me put it down here, actually. All right. And then you would have 8, you have 48. And then you have 3q equals this, because this will cancel out. This will we end up with left. Then we would go to the next step, which we would take 3 and we'll solve 3 on both sides. And that would end up with 3q equals 48 plus 3. And then we would we'll still do the division for this, which is, I can't do that in my head. So we're going to so 3 goes into 4 one time, 3 times 3 is 3 times 1 is 3. We bring that down. Yeah, right. And then we have 3 goes into 18, 6 times 3 is 18. So then that would mean that 16. So this is this two-step equation done, by hand, the whole thing. And this would basically mean that q is equal to 48 over 3 or 16. For this answer, I'm pretty sure 16 is going to be what we have to put in. And there we go. So that's just what I need to make sure I remember. Let me move forward. All right, so let's go ahead and move through it now with knowing that that's the review that I basically did to make sure that I know what I'm doing. 3, 14. And then you have, this will be k over 4 plus 3. You can put 3 over 1 like this, and then we can go ahead and solve for 4 on both sides. Well, not on both sides. We're gonna basically find the greatest common factor by using these two multiples, 1 and 4, to get us to something that shows two fractions that have the same denominator, showing that they're equal, because we have a variable inside the equation. So that would leave us with 3 times 4, that's 1 equals 14. And then you have k plus 4 equals 12. And then you have this, and then that also will be equal to 14. Now, you can go ahead and you can move up another step, like we do all the time, in these small videos, where I would just take the, not duplicate, you delete this, you go ahead, delete, and we put this here. And I'm just being a little creative when it comes down to putting these videos together. So now we have k plus 12 over 4 equals 14. Now we have something where we could try to get k by itself. One thing we can do is we can probably go ahead and remove this, right? Because I'm looking at it now, we can actually have we got actually solve for 12, well, solve for k by putting 12 on this side, 12 on that side. This will leave us 2, because 14 minus 12 is 2. Then we cancel that one out, and we just end up with k over 4. And we can bring this down. Oh, actually, I just want to duplicate this. It's over here. And does that look like we can? What else can we do with this? I can go ahead and we can put the 4 over this side, right? And then if we put 4 over here, we have to put 4 here. That doesn't look right. I think I'm actually going a little bit way above, but doing that. No. I actually now I remember what I was supposed to do. Okay. This is almost right. Almost right. Almost. All right. I'm going to just erase all of this. We're going to go back to what I was doing before. Okay. So what happened was that we don't add that 1 over there. What we do is that we solve for I think we solve for 4 on both sides, something like this, right? And then that would lead to 12, which what we got before. This would cancel out, and then we would end up with this. Then we would go ahead and have 2, and then k would equal 2. So now if we try to plug 2 back in to check, you would have 2 over 4 plus 3 equals 14. Okay, and then we would have, this would basically say, I think that's k which is 12. So it just says this. Why am I lost with that? It can't be 2 then. It's out for 14. All right. That's not it. It's solved for both sides. Yeah, it's solved for 3. Okay. So we subtract 3 from each side. So we don't have to, all we have to do, that's what we do first. We have to subtract 3 from each side. That's, yeah, and then we end up with 11. And then we have k equals 4, not equals 11. This is k equals 44. So in order to get k equals 44, we have to multiply 4 on both sides. Now it'll be 44, and it's k. And now we plug 44 back in. Now we would get k equals 44. Over 4 equals 11 plus 3 equals 14. Yeah. No. So that was my little hiccup there. All right, so what I'm gonna go is go back and do that again. So we have the same thing here, just like what we had in the last problem where we had this and k ended up being 44. We're gonna have here this h over 6 minus 1 equals -3. And then what we do is we get this solve for 1 on both sides like we did before. And then this would bring us down to -2. So h over 6, which would leave us h over 6 equals -2. And then we would have the next thing, which would be to get 6 on both sides. So this is also this. I'm used to that. And then that would be -12. And then it would be h equals -12. And then we would check. And then you have -12 over 6 equals -1 equals -3. And then that would be, this is a 1. And then that'll be, this will basically be 12. -12 over 6 is basically 2. So you would have end up being -2 minus 1 equals -3. I mean, 12. Yeah. Kind of try to bring that back whenever I do it. So we have 9 p over 4 equals -18. And then we would have, you have 9 times p is 9p. And then you have 9 times -4, it's next to -36. So we have -36 here. Then we have, now we have an equation we can start to break down. We want to start to solve for p by adding 36 to both sides. This is pretty much like this. Looking at this equation is kind of saying you have $36 and you want to buy something for $18, which would leave us with a positive 18. I'm going to move this up. Whoops. Yeah. I'm going to put it over here. Yeah, I'm just going to get rid of it altogether. Okay. All right. All right. And then you have 9p equals, you said 18. All right, then we have to go ahead and solve for 9 on both sides. I remember doing this. We put 9 over here, we put 9 over this side, we end up with p equals 2. Then we can check that on this side where we have 9, we have p equals 2. So this is plug in p. And then you have t minus 4, and you have equals 18. So this would, now we would do this whole situation, which ended up with 36. Yeah, and then when we do this, this would lead to a negative 18. So the answer would be p equals 2. All right, now we can move on to the next one, which is 6 equals 2y plus 2. And then we have solve for y, which is 2 over y plus 2. So first we do is the distribution. I call it the distribution method, where we multiply this and that together, we end up with 2y plus 4. And then you have it's equal to 6. And then what happens is that we would solve for, we'll put 4, we'll cancel 4 on this side of the equation. And on this side of the equation, we will bring it over here to, down to 2. You have 2y here. Then we will cancel the 2 out on this side. Cancel the 2 here. And that would leave us with 1y. 1 equals y. And we can check that, which will be 2y plus 2. And then that's 4. Yeah, that's not right. It's 2. It's 2. That's what it is. It's 2. See, that's why sometimes you start canceling just to cancel. It's 2 because in order for this to work, now this is 2. You put y equals 2. You can see that 2 times 2 is 4. 4 plus 2 is 6. No. What did I do wrong? I feel like this. Was I right before? Yeah, I was right. But then if that's 2 plus 2 times y, 2 times y, 1 plus 2 plus 4. Oh, wait, I was actually doing that totally wrong. Totally wrong. It's that. Jesus. All right. All right, so let's go ahead and we put 13 equals 2m plus 5. And then we would have basically the 5 on this side. Inside leads to 8. And then we have this side over here. This is 4. That's m. Now we have this one over here. We have 3 equals g minus -4 minus 5. We could do the same thing we were doing before, where we'll put 5 on both sides, so it leads to 8. Then we would have g 4. When I did this, what I would do is that you would solve for -4 on both sides, right? That would leave us with 8 times 4 would be 32, but 8 times -4 is -32. And then we would end up with, this would cancel. And then we have g. And then it'll be g equals -32. Okay, so I think I just spent practically a little bit too long on that, but I'm going to try to do that one more time to get the numbers right without talking. All right, so we have -30 equals 5 times x plus 1. This would be 5x plus 5, right? Well, there's no parentheses there. Which would lead to -35. Yeah. Negative. You solve for t, you have 2 minus t plus 1 equals 10. And then we would have the distribution. No, it's 10. We're just going to remove that. Okay. And then we would have I'm going at both sides there. We would end up with t equals 8. And then you would have 4. Okay. So you have here 2 equals m over 2 equals 7. This is something that we had before. We just start with here with m to 7, 9, 2. Multiply 2 on both sides, we end up with 18. We end up with just m. Then we can try to plug this m in here. We have 2 equals 18, 7. Does that work? Yeah, it does. Because 18 divided by 2, 18 over 2 is 6. 18 over 2 is 9. 9 minus 7 is 2. So the last is going to be 18 equals m. M equals 18. And we have this one. We will use j minus 2 plus 7 equals negative 12. And then you have here, we have negative 12 minus 12. And then that would be negative 19. And then you have j, and then you would have, redo the, what do you call it again? Multiply 2 on both sides, which would leave us with just j by itself, and this would be 19 times 2, which is 38. Yeah, negative 38. No, 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 no. It's negative 12. Yeah, negative 12 minus 7 is negative 19. Oh, wait. It's not that. It's that. So you have negative 9, it's 5. So you have j equals negative 9.5. So I'm just going to check it real quick. Negative 9.5. Negative 9.5 plus, yeah, negative 9.5 over 2 plus 7 equals negative 9.5 over negative 2 plus 7. 11.75. I'm still missing something. Let me just do that again. This will be negative 19. This will be j over negative 2. That you would put, or maybe I'm doing complete, maybe because I have the 2 there. Or it's not, it's just 19. Negative 19, yeah, negative 19 to negative 9 is negative 9.5. And then that would be J. Well, let me just, I have to go back and look at how it would be if it was just 4 plus 7. So to say it was just J plus 7 equals negative 12. And then what happens is that you would have negative 19, right? And it would be J equals negative 19. So what's the problem? What happens when we have J over 2? Now, well, in order to solve for J over 2, you'd have to kind of make 19 have a half, and that would be negative 9.5. And then having the 2 on this side, you would multiply by 2, and then you would get J by itself. Or you don't do that. Let me see what I did wrong. Yeah, multiply negative 2, and you get J by itself. And I'm supposed to actually add that, I'm supposed to multiply that side. So once I multiply both sides, once I multiply each side, both sides by themselves, then you have J over 2 equals negative 19 times negative 2. Yeah. All right. So that was a goof on my end. So let's go ahead and try it again. I remember this answer. I'm not going to. It's not going to say. I'm going to go ahead and start again. 19, negative 36, 18, 36, 36. And then this would bring us down to 18. 0 is 9. And then you end up with 9p equals 18. And then we would solve for 9 on both sides. And that would end up with 2 minus p. But that's the steps to get there. And then this one, your 41 is 12d minus 7. And then you have 7 on both sides. Like this, you need 48 equals 12d. You use 12d on both sides to bring this. This would be 12 times, well, 12 times 5 is 30. And 12 times 5 is 60. And 12 times this 12 is 4. So it's 4. This gets canceled out, and with d is 4. Okay. And then you have here, negative 13 equals r over 9 plus 8. And then we would do what we do before, just by itself. This would be 21, negative 21. You have r over 9, like we were doing before. So what happens that at 9, this we solve for, we multiply 9 on both sides. And then I'm going to see something. Multiply 9 by both sides, we end up with 9r and over 9, right? This is why, that's why this cancels out. Because if you multiply both these over 9, you have 9r over 9. This is just like saying r. You know, I'm looking at that. We could say, you know, if r equals 2, you know, and then we could say, you know, 2r over 2 would be would basically equal 2 times 2 over 2, which would basically mean 4 over 2, which is just 2. And that's I have sometimes I'm going to refresh my memory doing that, knowing that that's why that happens. Sometimes I forget that. Anyway, moving forward, we have -2 times 9. If my calculations is right, this is going to be 189, -189. And then we just have our, so now we do 180, -189 over 9. Now we have -189 over 9 plus 8. Yeah, and then plus 8 equals 13. 13. So the answer is -189. Okay, so that's a little bit better than I did before. I will probably go ahead and do word problems in another video. Not going to rush it. The idea is just to take my time and make sure that I'm actually learning the things I'm trying to put together. And then I can even use these videos that I'm doing as a review before I actually go ahead and do the the word problem again. I can actually see these things and kind of use them as a review method for learning other concepts. It's one thing about this idea is that I'm actually struggling with my old way of doing things, the old way of like solving problems, which is just doing it over and over and over again and just seeing what happens. If I do a pass, I pass. I don't. And then like there's this way of doing it with the open source, looking at your work, being able to not have to spend time searching for the answer from other people, taking the answers that you get from other people, coming up with something a theory that you can use that makes sense to you, and then using that theory to explain what you're trying to do. And and you continue to use that theory as long as it's continuing to work. If it runs out, if it stops working, then you need to stop, evaluate what's not working, update or refactor that code that code is a software term, but that's basically how I'm looking at it. Where I try to reject anything that's not working in my thought process, and try to add something to it that does work. You can leverage what the people are doing and saying, but everybody's trying to get closer and closer and closer to the correct answer or the correct way. There's multiple ways of getting to that answer. It's just that sometimes that we're not necessarily clear on how it is. So, and sometimes for me, doing this live allows me to remember that somebody might see it. So my mind is trying to do the problem as if someone actually is there, rather than it being just me in the room by myself. Anyway, take care. See you guys next video. Hmm. Oh. Oh. So basically, this is going to be a video where I go ahead and something like that, all the way from A to Z. So the idea is to go ahead and not too fast, can't figure it out, but there is a way to go back and look at the so right now, it's you can always go ahead and check out these videos. But I went ahead and I made a collection of like 2 sets of videos. It's from the videos. As you can see that we have 3x number multiplied by coefficient. See right here. Equal you want to go ahead and do it by itself. If you have attached to that plus 2. And then down to the bottom, you can get not the bottom, you want to probably get it by itself. So now, you x equals 12. This looks really what to address that. You have to balance these out, scale some sort of scale. It's how we get together. It's make sure that the amount of inside definitely still inside 6. Alright, so then you're going to go through start. So what I actually did from that's it. I'll go ahead and do that. So this is basically the 2 separate versions. There's a lot of things. But there's 3x plus 2 equals 14. First by solving this equation by getting 2 by itself by putting 2 on both sides. And you would 3x equals 12 because this will cancel. So 14 minus 2 equals 12. And 3x on that side, division cancellation. Division to cancel it by itself, giving you x equals 3. This is another point series that I made, but this is how we actually so we're going to go ahead and just take this to that's as long as okay, and we'll be able to work on this. Alright, so 41 is 12D minus 7. And I was saying before, what we do is that 41 on this side, 12D minus 7 here. Just the is also. And first, you want to solve for that's the way I was taught. I got to remember and solve for d by itself because that's this variable is actually the most